Okay. And then, but today's topic, even though the time series forecasting, but specifically, like we want to introduce the algorithm called Prophet. Okay. So before getting to the Prophet, so the time series forecasting itself is basically the application of supervised training or supervised learning. And basically, you build a model to predict the value from the past data, right? Based on the past data. And then using that model, then you want to predict the future. We call it specifically forecast the future. And that's what that time series forecasting is. And traditionally, this time series forecasting itself has been an old technology, old method, right? And one of the typical ways, sort of like, for example, when you have day 1, day 2, day 3, and then you want to basically predict that, day 4 based on day 1, day 2, day 3. And then you kind of like shift the time window little by little. And then like you want to forecast the next day, this is just one of the many ways, but it's a very typical way of doing that time series forecasting. Well, so there are some problems with the traditional approach. I'm not trying to say that traditional approach is bad or wrong, anything like that. It's just that it's sort of like a good and bad, right? As everything in the world. But the challenges of using traditional time series forecasting method is that the data needs to be in a certain format or in a certain form. So, for example, time interval, for example, first, second, third day of the month or something, has to have the same interval. You can't have like 1 first and a fifth and a 6, 7, 8 or something like that. You got to have the same period. If it's day, you got to have like 1, 2, 3, 4, 5, 6, 7. And then you can't have the NA. So it's very weird. The model doesn't really work well when you have like NA value for certain days. And also the seasonality becomes important for the time series. So like, for example, weekly seasonality, like yearly seasonality. Weekly seasonality meaning like Monday sales is high and then like Wednesday is down, that type of seasonality of the week. And then yearly is the more like monthly trend, right? So like, for example, summer, like the August and July and August, we have higher sales. And then when we have like a lower sales in like, let's say February and March or something like that. And then, so at the end of the day, the parameter tuning becomes a very important task for using this kind of method. And that is where like, we need a sort of trained specialist to do this time series forecasting. So then here comes a Prophet algorithm. It came in, I believe, beginning of last year, if not that year before. But folks at the Facebook built this algorithm, and in Stan, which is a Bayesian side of programming language, and then expose it to R and Python. And that was it's a huge revolutionary thing. So, at the beginning, many people were kind of a little suspicious, especially you're coming from the traditional background. But then soon they started finding the great result. They started producing great results. So now pretty much, actually many people are, more comfortable using these algorithms. And our customers also, like I'm hearing producing great results as well. So that's the part like I like to introduce today. Okay. So what is that inner working? I'm not going to go into too much detail, but this is more like kind of very high level. But what is really different from the traditional approach is that it basically is a curve fitting. It's like kind of machine learning, right? So try to find, like based on your sort of time series data, like let's say like sales going up and down and whatever imagine the line chart, right? And then try to draw the line to match that, original line. That's essentially what it's trying to do. But how it does is that it finds, first of all, the overall growth trend. Like going up or going down. Maybe sometimes, like at some point of that time period, there's a change point, and start going accelerating, going up, or like maybe start going down instead of keep going up. But nonetheless, you find the overall growth trend. And then you find yearly seasonality. This is like a January or February type of thing. And then a weekly seasonality, that is like a Monday is higher than Tuesday, that kind of stuff. And then also another thing called holiday effect. As you can imagine, we would have more sort of sales increase around Thanksgiving Day time period. In certain countries, more like in a Christmas time or summer. So not summer. It's particular holidays. And also imagine like you're the company and you do sort of like an annual conference, and then around that time you expect more page views or more sales. That case, holiday doesn't have to be a national holiday. It can be like your unique sort of like a special days that can happen like every year. Okay. So so this is the chart. I mapped out like each transaction sort of. This is the data of the page view of Apple's Worldwide Web Conference, not worldwide, Worldwide Developer Conference page. And then each day, the unique page access page views is basically expressed on the y-axis. Okay. And then when you draw the trend line, I mean, like when you use the Prophet and the Prophet can find the trend, it's sort of like when you look at this orange line, it's kind of going down up to 2000, I think it's like between 2016 and 2017. And then after that, it's like kind of picking up. So that's like a general trend. And then instead of drawing that dot, like you might be more familiar with like drawing the line by the line. Drawing the line, connecting all those dots. Right. And then obviously this trend itself doesn't really give you the good capability of forecasting or predicting. So, but here is things start coming more interesting. You also find yearly seasonality, which basically the same trend repeat every year, right? And then, for example, in this chart, somewhere around like before July, so June probably, the green line kind of picking up, right? And then so every year you expect June to have like a higher increase probably. And then like also like there's up and down, so like every month or something like you have a different trend, and so that's the yearly trend. So now, next thing you want to do is like you basically combine. By the way, you're not going to do it like this. What Prophet algorithm is actually doing behind the scene. But what is going to happen is you combine this trend, general trend, and combine with the yearly seasonality. And then when you draw the line, like it becomes something like this. And then this line started kind of like mimicking the original blue line, which is the actual values, right? Then like you want to add weekly seasonality. A weekly seasonality, like you see here, is like sort of like repeated every week in the same way. So, maybe like Sunday going up and then Saturday going down or something like that. But you want to add this, Prophet algorithm adds this seasonality on top of this like orange line, then you get something like this. And this becomes even better in terms of like how matching this orange, which is a forecasted line, and the original blue line. Okay, so this is what we have by combining trend, yearly, and weekly seasonality. And then you want to combine holiday effect. In this case, this is like Apple's Worldwide Developer Conference data. So like we fed the conference days, because usually the page view pick up around right before the conference days. So or maybe like around that time. So like we fed that information, and then gives the Prophet algorithm find this holiday effect, and then like you combine holiday effect into the mix. Then you get even better line, basically kind of like very close to the original blue line. And then, by the way, like when you look at here is the orange lines after January 2018, you see only orange line because we have the data only up to January 2018 for this particular case. And then the orange line is the the one like forecasting so in the future. So it's forecasting for like next whole year. Then even like kind of a very right hand side, you see like a huge pick, and that's coming from the combination of this trend, yearly, weekly, and holiday. Especially the holiday effect is it's much higher. Okay, so but that's just very nutshell, higher level of understanding of how the profit algorithm works. But the benefit of using this is that like you don't really have to worry about the time that the data that you have, because it can take care of uneven time interval data, and also it can take care of the NA values in the data. And then also you can have like weekly, yearly seasonality at the same time. You don't have to handle separately. And then also the latest release, it also have a daily seasonality, which is, you know, during the day when you have like, for example, hourly data, it might be, you know, like 2 o'clock in the afternoon, like you have more access than the 9 o'clock in the morning, you know, that type of seasonality can be added as well. And then it's really amazing thing here is that it's perfect for like the people who just start using this, getting into analytics, is that even the default parameters can give you the, you know, pretty good, decent result. And then if you like, you can start kind of tuning the parameters to make it even better. But the important thing is like, even if you don't have any background, you still can get a pretty good result. Well, you know, of course, like the data has to have some kind of trend. It's like if your data is kind of like a crazy, wacky, you know, no trend data, then, you know, algorithm can do only so much. Anyway, so like from here, like I want to see, like I want to show you like how you can actually do by inside Exploratory real quick. So. So here, what I have is this like a sales data I have, and then okay, and then what we have here is like order date of the order, so the date of the order, and also there are a couple of the measures. One is sales. So let's see like how we can use this data and forecast the sales in the next, you know, 1 year or 3 months or whatever the period is. Okay. So first, like I want to show you like what kind of data this is really, is that if I go to the chart view and then like I'm gonna assign order date. Let's take a look at the data by weekly. And then like obviously kind of, you know, going up and down. But looks like though, like you see, like there seems to be some kind of pattern, and which is that, for example, 2012, December is the highest. Oh, sorry, actually this number of rows, this is like a number of orders. Each row is actually the order, so number of the orders. But let's see the sales, for example. And it's pretty much the same, but December is the highest. And then next year is actually November is the highest. And then another year is December, and then the latest, like 2015, is November. But like you can see, there's kind of a general pattern of like each year. It starts off kind of slow, and then it's gradually getting higher towards the end of the year. Right? And then what the question here is, we have the data up to 2015 December, but what is going to happen in the 2016? Obviously, like you never really do for the forecasting for the past, but let's imagine, pretend this is a 2015, and we want to see like what is going to be like in the next year, which is a 2016. So to do, go to the analytics view, and then under the type, like you can select a time series forecasting bracket profit, and then assign a date time column to be order date. And then you can set that like whatever the day. I'm going to go with week first. And then the value is, let's select the sales. And then click run button. And then you get the false forecasting model and forecasting in the future. So here you see this orange line, and that's the forecasted values. And then the orange line, after this point, let's say 2016, we have only orange. And up to 2015 December, we have the actual value, which is this blue line of sales, right? And then, so what's happening is behind the scene, you build a profit model and then forecasting, and including even like in the past data. And this is what the model is telling us. If there's no based on those like seasonality and the trend, it would be something like this, right? And then you see some kind of like a kind of upward trend. Okay, and then this like a kind of orange, like a light orange color range, that is very similar to confidence interval. We call it like uncertainty interval. But basically what it is should probably resize in this range. If not, it's on this orange line. Okay, and then you can go to actually here. So it's forecasting only this much of the period, right? But let's say like we want to forecast the whole year, not like up to here is like, oh, it's forecasting only up to March 6th, but we want to forecast the whole entire year, which is up to December. And you can actually change those settings from this property dialog. And then you can click on this property dialog, and then here forecasting time period default is 10. And this period unit is based on what you selected here. So right now, like we're looking at the data bi-weekly. So that means the 10 weeks. So this forecast is for the 10 weeks period. We want to do it like for years. So like let's say 52 or whatever the appropriate. So like let's say like, I'm going to just go with the 52 weeks and then click on apply button. And this is going to give you much more wider, sort of longer range of the prediction. And what's cool is like, of course, like if you predicted up to here, it's like you see, you can understand like the next few months. But what you want to understand is like a whole entire year to see like what the trend is going to is telling us, because the December and the March is completely different in terms of like amount of the sales. So now like this is the area that whole next year, and then like the blue line area is the past, right? And then like we can also go to the trend tab, and this gives you the view, not just this like orange line is a general trend, but also this green bar is telling us that trend change or the change point in a way. So this much of that, for example, trend change 0.03, meaning 3%, the trend has changed from the previous period. And then the higher this value is, by the way, so this values are expressed at the Y2 axis, right-hand side. And higher that is basically this orange line is supposed to be the straight line, but like many times it's actually changing that sort of like an angle or slope. And then that's happening around this time. So for example, this one is 2014, around like a September, October, November period. Seems like the sales kind of like picking up. Like when you have the business, like like sometimes like there's some kind of inflection point or some points that like a trend start picking up, or either way, opposite way. So that's the trend line. And then when you go to the yearly, and this is actually pretty interesting because here we see, for example, June. This has only from January to December, and because the yearly trend, what we care is like which month has higher compared to others. So in this case, June is higher. And then another thing is here is like a September and then November and December. And these are the period that like we tend to have like higher sales compared to other. And then every year we expect this much of a difference. And when you go to the weekly though, we don't have anything. And that's because weekly is supposed to give us the seasonality of like Monday, Tuesday, Wednesday. But our data is aggregated by week. So in order to see, for example, which day of week has more sales and that kind of stuff, then you can actually change this to forward to date and then run again. And then this is now aggregating the data, the day level. And then here under the weekly, we have this seasonality data being visualized. So I can see here is a Tuesday and a Wednesday. Oh, it's pretty much like after Tuesday to Saturday is the sales tend to be higher, and the Monday and the Sunday, Monday tend to be drop. So that's the general trend for like weekly. And then we can see, the forecasted one, and then like it's pretty crazy here because now the data is daily level. You can actually kind of zoom into a particular section, and then this is what how it looks like, and it's more kind of granular level and of the data because now the data is aggregated at the day level. I'm going to switch back this to week again, but this time another cool thing you can do is to see that is there any difference among the market or region, country, or product category, right? So this what we are looking at here is like all entire order, right? Regardless of region or product or anything like that. But you might want to kind of create different groups, and then each group might have a different seasonality kind of stuff. So you can actually use this repeat by and then assign, for example, I'm going to use this market. What is market is that here, the summary view, we can see there are 5 markets like Asia Pacific, Europe, and USCA is North America, like United States and California. Not California, sorry, Canada. And then LATAM, the Latin America, and then Africa. So we have like 5 different markets. So let's see like how we can forecast in each market. So you can change that to here is the market, and then click run button. And then behind the scene, it is creating the 5 different forecasting model and the forecasting such. And by looking at here, you can see that some sort of like a different trend here, right? So for example, the Asia Pacific, it's like in the first half of the year is kind of slow, and then picking up around June, after June. And then USCA, for example, on the other hand, is pretty quiet. And then like at the very end, like September and then November, probably Thanksgiving period, sales start picking up. And then, so each area, each region has a different sort of like a trend you can see. And then, by the way, so this repeat buy is using, for example, Africa sales is much smaller than like other market. And in that case, you might want to ignore this scale, or it's up to you. Sometimes it's good to have the same scale for all the charts, but you can actually change it. If you like to change, you can click on this chart property. And then this like right now the sync y-axis scale, but you can actually uncheck it. Then this is gonna kind of zoom in for like give you the kind of optimized y-axis here. So now like you can't compare like side by side, but at the same time you can focus on kind of what's happening in each chart. And then like you can also go to, let's say, like yearly tab to see the seasonality and then what is the seasonality in each market. And then like we saw already is like uses USCA like September, November that tend to be higher. And then, but Europe on the other hand, the highest period is more like June and August. And then, so like each region has or market has different trend or seasonality. You can see that from here. And then like the last tab is like a data tab. And then like you can actually export this data to create a new data frame or generate a CSV and then share with others as well. So that's a very, very basic of the profit algorithm. There are a few other topics that I think it's really cool. First is holiday effect. We basically talking about yearly seasonality, weekly seasonality and trend, but I haven't shown you like how to incorporate the holiday effect. And the next topic is that, like when you build the model, especially like machine learning model type of things, you want to see like how this model is sort of like trustable, or like what's the quality of this model, how much you can trust this model to see, keep forecasting the future, right? So that testing, evaluation of the model is also another topic. And then some few other topics, but I'm going to share that in the slide. But so let's go tackle those two. But I want to actually start with the testing or evaluation of that model first. So to do, let me just go back to the slide. Okay, here. Basically, what we want to do is like this. There are a few ways to do it. There are a couple ways to do this kind of evaluation. And one of the way is commonly used something called backtesting. So backtesting is nothing but like we have the data from January 2012 to end of 2015. And that's the old data we have. Then we basically split the data between the training data and test data. And test data is the sort of like last period, towards the last period of that data. Let's say like we want to say like we want to use the 1 year as a test data. And that means in this data, we have like 4 years of data. So that we want to use 3 years of the data as a training data. And we want to use the last 1 year of the data for the testing data. So Prophet algorithm will build a model based on the training data and then forecast. And then we want to compare the actual data that we already have and against this forecasted data. And then we see the difference between, in this case, the light blue line and then like orange line, which is the forecasted values, and see like what's that difference between those. We call it error, but basically the difference is between the actual or the answers and the forecasted values. Okay. So, and then there are a few metrics we're going to talk about. And the detail is that I'm going to share this slide later, and then you can take a look at it. And here, each metrics, we draw some map, so that will help you to understand what exactly it is. The main thing is RMC, root mean square error, which is really the kind of common parameter to see the differences between forecasted and actual values. And then this involves the calculation of square and then root but there another way to do, which is like mean absolute error, which is no squaring or rooting, instead of focusing on just absolute values of the difference. And then so those two, like RMSE and MAE, tend to be sort of like influenced by the raw values. So like when you, for example, have, just one sec, looks like let me, oh, okay. Kind of new position will be muted. Okay, cool. All right. So there was some noise, so like I muted you guys all. Okay. And then, so those RMSE and MAE tend to be influenced by the original values. So in our case, let's say like Africa, sales in Africa tend to be smaller than the sales in North America. So you can't really compare, for example, RMSE or MAE because those are based on the real values. So in that case, we can use some other type of metrics, like, for example, MAPE, mean absolute percentage error, which is nothing but like absolute percentage difference between the actual and the forecasted. And then like we just take the mean of that. So the detail, how that calculation works in these slides, and you can take a look at that later as well. So now let's see like how you do it. You can do it inside Exploratory. So to do, you don't need to do this like a repeat by. Let's start with this, and then but here is a property, and then at the very end, at the bottom, it says test mode. you can change this to true, and then you can click apply. But one thing though is how you decide, the splitting period. So like what percentage of data to be testing or training. Well, you can decide what is the period of data you want to hold or preserve for the testing here, actually. So this is 52. So basically, we want to take that, like whatever the last year to be the testing section, or have the forecasting section, and then like the rest, the remaining years to be the training, which the algorithm will use to build a model. So here, like I'm gonna just click on the apply button. And then like what we got is a couple things. So here's blue line, which is the actual or in the training period up to December 2014. And then this light blue, which is the testing, the actual data for that testing period, which is basically the 2015. And then this orange is the line that like this model is forecasting, or the values that like a model thinks it should be around this time area. And then like what we want to see is basically go to the summary view, and that's where like you see like RMC, MAE, or this type of metrics. And then like you can see other like for example area as well. But this now like basically we are looking at is the same seasonality trend, yearly seasonality, but this one is not considering the 2015 because that is left for the testing. But now, like here, like when you look at the summary view, like it's RMSC 17. What that means? Well, like about like 17. In this case, x-axis is this is like a training. Yes. So this much is the difference, but sorry, it's like $17,663. Would be this is a kind of think of it like average. This much would be different, like when you get the forecasted values. So that's actually cool, and this is MAE as well. But you want to actually compare against something. Otherwise, you can't really tell like this is good or bad. So that's where like you want to actually, for example, you can use a repeat by, and then let's say like let's use that market again. And what this is going to do is basically the same thing after splitting the data, and then like create a models for actually creating a model for each market, but each market has the data being split between the training and then the testing data video. And from here, what we can see is like, let's say like when you look at the RMSC, and then Africa is the smallest, and then the Europe is the biggest. And then MAE usually have the similar trend, and like Africa is smallest. But this doesn't mean that the model for the Africa is better because the error or the difference is much smaller than the other market. Because like I said, the Africa, the sales amount, the value, raw value itself is already pretty small compared to like something like Europe, North America, Asia Pacific. So it's not really like we're comparing orange and orange. And in that case, you want to compare by using this MAPE or MASE, and because these are more like a ratio. So here, what we can see is this like a percentage ratio. That actually Africa is not really doing well. The model for the Africa is not doing really well compared to something like Asia Pacific. And then like what that means here is again, we are talking about essentially the difference between this like a light blue and orange. And then you see here is like a kind of blue is always not really along this like orange line as compared to here. This like USCA, and then like Asia Pacific. This is like a kind of the smallest, and it seems like all the blue lines are not necessarily on the orange line, but at the same time within this like orange like uncertainty interval range. Okay. And then, by the way we actually use, or many folks actually use, is not necessarily pinpointing the exact predicted value or forecasted value, but you can actually use this algorithm to identify sort of like an unusual movement, because the model, once you build, is telling you, hey, it should, whatever the value should be, resides within this range or along this line. But whenever like you see some value deviated from that, or even like outside the range, that's where like you usually there's some kind of a weird behavior or some kind of unusual thing happen. Doesn't necessarily weird, but some kind of surprising thing going on, and then that will trigger you to do further analysis. So in a sense, like you're basically doing an outlier detection, and then many people actually use it, including us as well. Okay. So that's how you can do the testing by using this property here. And I'm gonna move on to the next topic, which is the holiday effect, right? So I'm gonna switch the data set to something else, which is the Wikipedia data. Here, let's just, we downloaded it some time ago, so data is not really included in the last few months or something. But this is like, again, Apple's Worldwide Developer Conference, like a wiki page data. And the numbers you're looking at here is like how many unique page views. Okay. So 2015 July, we had 186 people or the computers access to this page, right? And then like, we can draw, go to the analytics, and what we can do is doing the same thing, right? So timesheets forecasting and the date, assign the date, and then this like a day is fine. And then instead of number of rows, we want to have this page view forecasted. So click the run button, and then it builds the model, and then gives us the forecasting, which is the orange, and then the actual value, which is the blue. And then we can see like a trend and a yearly, and basically the same thing, right? But let's focus on here. And as you see, though, it looks like when you look at some of the data, seems to be doing well in in terms of like a forecasting. It's kind of like it somehow managing to get the weekly seasonality and also yearly seasonality. But then there is some kind of a weird spike, especially these three things, right? And then obviously these are not well being captured. And then this actually turned out that like, these are the days that they had worldwide conference. So people tend to have higher access, tend to access to the wiki page because they Google or whatever. So and this part is not being captured well, and that's where like you want to do add holiday effect. So how we do it is that you want to have this like a holiday column, that column that contains that holiday information. What do you mean by that? Well, so here like, we want to have another column to say, hey, this is actually the holiday or not. So so that type of like identifying information. And we don't have that here, but I created this day by checking which dates are, the conference dates in the past. And also we know somehow figured it out from some people that in future, in 2019, these are the dates, this is actually fictionally, so please don't trust. But these are the dates that, they're gonna have the conference, right? So this is like the holiday information. And in your case, probably like you might have like your company's information, company event information, or simply like Thanksgiving or Christmas or whatever you have here, right? But you want to have like a date and then the holiday name and whatever the name you have. And then you want to actually add this data to the original data here, main data, to so that you can feed combine data together into the Prophet algorithm. And how we do it? Well, it's very simple, right? So you can actually join them together. So you join these two data frames. And then, so you want to, let's click on the column header of the date. And then there's a join, add columns from the column header menu. And then like you want to do is select the data frame that you want to join with. In this case, WWDC underscore date. That's where the holiday information is. And the target column here is a DS. So what this is going to do is basically both of them are kind of a data type, which means like a year, month, day. So we want to combine them together. Sometimes you might have, like, let's say, like the data as a project CT. CT stands for calendar time. So it might have like a time data too. And in that case, when you try to join, you get the error because you can't join between date and projects. And in that case, you want to convert the projects to date, or either way, convert the date to projects or something like that. But anyway, so this is how you can join. But one thing to note here, though, is that you can't use a left join. You want to use the full join. Why is that? Well, because if you use the left join, at the end, after this joining operation, like you get only the dates that are in this data frame, this main data frame. But you want to bring a future date which don't exist in this main data frame. And in that case, the full join is basically keep both data from like a target and a current. That's actually the full join. So so that's the operation you want to choose. And if you want to know more detail, like we have some tutorial around join under exploratory.io/how-to URL. But anyway, so let's join this. And what is going to happen here is that there's a new column. And I'm going to increase the number of rows here. And then so that like somewhere around maybe June here, like we have, so these are the some dates that has a holiday information. And then other days are actually just an NA because those dates don't even exist in the WWDC underscore dates. Okay. And at the end, you know, there will be some like extra 4 or 5 rows. Those are like 2019, right? Okay. So once we join this, now we are ready. So I'm going to go to analytics. And then here, holiday column, like that's where like we want to add the holiday column here. And make sure though, like here's a pin. Sometimes pin is, you know, kind of a green color. That means this analytics is pinned to the particular step. And then after that, when you join, and then you go here and then, hey, like I'm not seeing the new column. That's usually because this pin is not coming from this join step. The data is not coming from the join step. In that case, you can drag and drop and move the pin position. Nonetheless, so you can select now that we can select the holiday column for the holiday column, and then just run. And then now the algorithm is taking and considering of the holiday. So here is this like an orange line is picking up really high, and then it seems like it's capturing pretty well around this time as well. And then, you know, even then, sometimes not much, but pretty much compared to before, at least for this like a conference period. And then what we care is like a next, you know, how that is going to be like next year. And then again, it's not forecasting for that whole year, only for like certain period. That's because under the property, the forecasting time period is only 10, in this case, 10 days. Well, we want to forecast for like 365 days for a year. Then like you can actually change it from the property, and then what? Not really. I thought like I changed this one to 365. That's weird. And then like, it build a model, and here the actual data is only up to here, like up to like 2018 in a certain period, but like now like successfully forecasting the whole year after that. And then this is where you know, in the future event is going to happen, and then that information is coming from the, you know, holiday table, event table. And then, so, you know, we are expecting this much of the page view around this time or something like that. Okay. So that's the holiday effect. And then we still have a few minutes to go. So I'm gonna just introduce a few other things. So another thing we have is the other parameters. But recently we added is this a trend upper limit and then trend lower limit. And then these two are sometimes like when you forecast, like let's say like something like a conversion rate or cancellation rate or something, and it never goes up to more than 50%, or at least like it never goes beyond 100%. But if you know the kind of upper limit, let's say like 30%, and then it's no point that even though like it's like a high, the trend is going up, like it's no point to see like a 60% or 70%. In that case, you want to actually type those upper limit. And same thing for the lower limit. Even though like a downtrend, but a certain measure never goes underneath lower than 0. And in that case, you can just type on a 0 or something. And either way, like once you set this upper limit and lower limit, then you remember the trend line here is usually this like a linear line. I think it's better to see from the global sales here. The trend line is always like a linear line, even though there's a change point. That's where like the kind of a slope get adjusted. But even then, like each section is always a straight line. But when you set the upper limit and lower limit, then the line becomes the logistic curve, which is kind of like an S-curve-ish things, because now we have like an upper and a lower, and then the model try to consider that type of constraint. Okay. So that's pretty much it for the introduction of the profit algorithms, and also like how to use inside Exploratory. And with that, like I'd like to open up questions. If you guys have any questions, please unmute, and then you can ask the questions, or you can type in the chat window. And all of you guys are muted right now, so if you like to speak, then you need to unmute, and otherwise, type in the chat window, either way. Okay, so some folks, sorry, Christopher is asking how to split the training and test data. Okay, so that is here. So here is a property icon at the left-hand side top. And then there's a test mode. Right now is a true. If it's false, then you want to change it to true. And then this will basically split. How you split is here. So this is like a 52. That means 52 weeks at the end of this data from the last side of the data, it reserves for the testing. The remaining can be used for the training data. And then that unit is always here. So like if this is, let's say like a month, and if you put 52, that means 52 months instead of weeks. And then what version of Prophet is currently support in Exploratory? I think it's, oh, thanks Hideaki. It's 0.2.1. Is there any updated version of Prophet would you like to see, or any particular functionality would you like us to support? And let me know. The latest release of the Exploratory 5.0, we added this upper lower limit, and also I think there's, oh yeah, and then this holiday effect. And then I think there's something we were working and we haven't delivered yet, which is an extra regressor. I think that's something we are working as well. So stay tuned. And also, by the way, though, this one is, we are doing it under the analytics view. This is sort of like really for kind of exploration, right? So that you can click button and you get that. But also another thing you can do is, instead of like using analytics view, you can access to, for example, column header menu or this add button, either way, to run the analytics from here. So you can see like a runtime series forecast. And what this is going to do is to create a step and then build a model, and then spits out the data that you see under this like a data tab. And then that's actually better if you want to build, do something else on top of this data, or you want to actually visualize in more like kind of custom way, and then you can actually create that step that way. And then by doing so, you have more flexibility in terms of like what parameters to be used, and exposed, and so on. But either way, like if you have certain things that like you want to do and in exploratory, but you can't do because the parameters are not there or something like that, feel free to contact us, and then we can help you how to do it. Okay. And any other question? Oh, okay. You like us to upgrade to Prophet 0.3. Is there any particular? Yes, we'd love to upgrade as always. But if any intraday data, okay, gotcha. So yes, we're going to add that to our to-do list for sure. Thanks for that suggestion. Cross validation focus area. Okay, yes, cross validation. That's actually a really good point. Right now, like we support back test for the evaluation of the model, and then we want to start getting into more like a cross validation side of things as well. And I note that this is not just for right now. We're doing it only for the forecasting, but also we want to extend this model to other type of models like machine learning and statistical model as well. So yes. You're going to see more continuous improvement in that area. So stay tuned. Yes, yes, for sure, absolutely. Yes, we want to make the cross validation more applicable across all the models, all the things you see under analytics view as well. Yes. Okay. So I think with this, I'm gonna end. We're gonna end this session. Again, thank you so much for joining, and